For this example here, again, we want to factor first, because with the factors will help us get zeros, and also they'll help us get vertical asymptotes and wholes. So the first thing is factoring. So it's important to factor. When I factor this expression, I end up with 2x minus 3. Sorry, it's going to be plus 3. And I end up with x minus 1. So just testing it, negative 2x, positive 3x. That's going to give me the positive x in the middle. The denominator is going to be x plus 4, x minus 1. You could always factor the easier one first and check. You can always check to see if there's common factors that might be involved to help you factor the other part. In this case here, we have something going on. We have our whole. Okay, so the whole is going to be at x equals 1, y equals, I plug 1 in, I get 5 divided by 5, so y equals 1. My vertical asymptote comes from the x equals negative 4 restriction. So I'm going to put that in there. So my vertical asymptote at x equals negative 4. And then my horizontal asymptote is going to be from my limit analysis as x gets really, really big. This ratio of 2x plus 3 over x plus 4, the plus 3 and plus 4 become insignificant. So ratio of 2x to x becomes 2. So it's going to look like this. So the limit of this ratio gets closer and closer to y equals 2. So there's my horizontal asymptote at y equals 2. Since now that I factored, and again factoring is a key here, now that I factored, I can find some coordinates. So I have zeros at x equals, well, this factor needs to be equal to 0, so it's going to be negative 3 over 2, always the opposite sign, back divided by front. And the y-intercept coordinate that I'm looking for is x equals 0, and plugging in 0, I end up with y equals 3 over 4. So I'm going to show that point, 3 over 4 here. I've got a 0 at negative 1.5 here. I have a whole at, it's like 1 and 1, so right up there. So my whole is going to be through that coordinate right there. And I can see that those 3 points, okay, are going to be graphed in this quadrant, and I'm going to graph through those 3 points like this. Okay. Now, we don't have any points on this side, but we should know that these should be diagonally opposite. And so I'm just going to sketch something relatively symmetrical through there. If you want more accuracy, which is not something I'm asking for right now, but you can plot some points in there. This is a cubic on the numerator and denominator, but the nice thing is it's already factored. So we're going to do the same thing. We want to look for wholes and asymptotes first. Once I've factored, I have some factors that cancel, so that looks like to be a whole. So as I plug negative 1 in here, I get negative 2. This one I'm going to have to do off to the side here. So I'm going to end up with negative 2 times 2 in the numerator. Negative 1 in here becomes negative 4 times positive 1. So I end up with negative 4 over negative 4. So that looks to be y equals 1. So at x equals negative 1, y equals negative 1. I have vertical asymptotes at x is 3 and negative 2. I'm going to draw my vertical asymptotes in. Okay, and again, these are the main parts of this function, are going to be the asymptotes. And then I need a horizontal asymptote. So the limit as x gets really, really big of f of x, when I look at this, the highest degree power is going to be 1x squared on the top, 1x squared on the bottom, so that I only need to worry about the biggest power terms. So 1x squared divided by 1x squared, as x gets really big, it has a limit of 1. So there's my horizontal asymptote. Now the one thing I want to make clear is we cannot cross vertical asymptotes. However, that is not the same with horizontal asymptotes, because vertical asymptotes are what we call local behavior, what's happening at that point. A horizontal asymptote is endpoint behavior, so it's only interested in how it's happening way out there and way out there. What's happening in the middle, the horizontal asymptote tells us nothing about, because we're going to either positive or negative infinity. We're not going to any local number, any number in here. So this horizontal asymptote is not something that is relevant locally. So we can cross it. We cannot cross vertical. We can cross horizontal. Okay, so let's make sure that's clear. Once I have my asymptote, this is the main part. I really want to get a few coordinates to work with. So I'm going to work with my zeros. My zeros come from the numerator. X equals 1 and negative 3. So at negative 3, there's a 0 here. At x equals 1, there's a 0 here. My y-intercept is going to be at x is 0. When I plug 0 in, I'm going to get negative 3 on top, negative 6 on bottom. So I end up with y equals negative 3 over negative 6. That gives me positive 1/2. So just be careful with that. Okay, so there's a positive 1/2 here. Now this is all I have to work with. So you really have to know what this graph looks like before you can draw it. So this is a double asymptote graph. And there's only a few variations of this. One of them, which this one follows, is going to follow the asymptote. It's going to go through that point and follow the asymptote. We do have to follow asymptotes here. And when I cross the asymptote, we're normally going to flip. So if I'm pointing down, I'm going to point up. So it's going to come down through here. It's going to go through my y-intercept. It has to cross the 0. And notice that it's okay to cross this horizontal asymptote. But there's nothing indicating that it's going to turn back up, because there's no 0 over here. So I just need to keep going back down. Okay, if you're not sure, we can always make a table of values and plug in some points to just kind of make sure we're going in the right direction. Now this is it that we have. This is all that we have to go with for points. We have to recognize then that as we cross this asymptote, we are now going to go from pointing down to pointing up. So it's going to come from the top and it's going to follow the asymptote. Okay, so it's going to look like that, and that's all we really know. Now, there are actually variations on this, and we cannot tell if this is happening, so I don't expect you to draw this. It is possible that it could go like this from the bottom, so we don't know. We just know that this is an asymptote, so this is actually a possibility. Okay, so we're not gonna worry about those things. We're just gonna, for now, follow the asymptotes vertically and horizontally and try to go through the points, and really that's it. Later on, when we start learning some more math and calculus, we start determining all these more variations that can show up in these graphs.